Let's take a look at this problem. At a school fair, you have a choice of randomly picking a ball from basket A or basket B. Basket A has 5 green balls, 3 yellow balls, and 8 yellow balls. Basket B has 7 green balls, 4 red balls, and 9 yellow balls. You can win a digital book reader if you pick a red ball. So let's look at that. Step 1 says simply complete the chart, write each answer in simplest form. So basket A, total number of outcomes. Well, we have 5 green, 3 red, and 8 yellow. We count those up. 5, 3, and 8, that is 16. How many of them are red? Well, that's right here. There are 3 red ones. So the probability is the number of red balls. That's 3 over 16. All right, let's look at basket B. Basket B, you have 7 green balls, 4 red balls, and 9 yellow balls. That was the total number. You add those up, you get 20. How many of them are red? That would be 4. So there are 20, and we want 4. And that's not in simplest form, so we can simplify, divide both the top and bottom by 4, and we get 1/5. Which basket should you choose if you want the better chance of winning? Well, you have 3/16 or 1/5. The better probability is basket B. Now, we should have those written down. If not, we're going to erase so you don't just skip to the end of the video. Moving on. A spinner has 11 equal sections, marked 1 to 11. Find each probability. So, you spin once and land on an odd number. Well, the probability of odd is the number of, odd sections over the total number of sections. So you start with the total number, that is 11. How many of them are odd? Well, if you count them up, you get 6. You can't simplify that, you get 6 over 11. Number 4, you spin once and you land on an even number. So we want the number of now even sections over the total number of sections. Total number of sections is 11, and there are 5 even ones. So you should write that down again. We're going to erase that so you don't just skip to the end of the video. What is the theoretical probability? You roll a number cube once. What is the theoretical probability that you roll a 3 or 4? Well, when you roll a number cube, there are 6 total options, and 2 of them are, 3 or 4. You can simplify that, divide them both by 2, and you get 1/3. Moving on to the last problem. Suppose you roll the number cube 199 more times. What would you expect the experimental probability of rolling a 3 or 4 to be the same as your answer to exercise 5? Now this is important because it's talking about experimental probability. Experimental probability is based on what actually happens. So do we expect it to be exact? No, we do not expect it to be exact, but there are 199 rolls, a total of 200. That's a lot, and the more that the event occurs, we expect it to be closer to the theoretical probability. So we're going to say no, but it should be pretty close. And that's it.